Hi guys, today we are going to talk about some more exponent properties. So we're in your notes starting on page 10, and the first properties that we're going to look at for today are quotient powers and then power of a quotient. So we're looking at when I'm dividing things that have exponents. How do I simplify those? How do I reduce those? So if I am dividing numbers with the same base, I simplify this by subtracting their exponents. So the top minus the bottom. If I'm taking some sort of fraction to a power, then the power applies both to the numerator and to the denominator. Okay, so those are the two properties that we're going to look at on page 10. So if we take a look at example 4, we're going to simplify this expression, and it says that assume no denominator equals 0. Having just come out of our rational functions unit, we know that our function or expression would be undefined if a equals 0 or b equals 0. So we're saying exclude that possibility and just simplify this guy. So I say I have a on top and on bottom. I also have b on top and on bottom. To simplify this, I'm going to subtract those exponents. So for a, I've got a to the 4th on top, and then since I don't see an exponent on bottom, that means it would be a to the 1st. So I would have a to the 4 minus 1, and then for b, 7 minus 2. So this would become a to the 3rd times b to the 5th, and that would be our simplified expression. For our second example here, we have a power outside of parentheses. I also noticed that inside my parentheses, I've got b on the top and b on the bottom. So I'm actually going to go ahead and reduce those first. You could distribute the power and reduce at the end if you wanted to. I'm choosing to reduce first. So I would have for my b's, b to the 5 minus 2, which would be b cubed. So I have 2a cubed, b cubed over 3. And then this exponent outside of parentheses applies to everything inside, everything on the top and everything on the bottom. So I've got 2 cubed times a cubed cubed. Remember, power 2 power means I multiply. And then b cubed cubed. And then on the bottom, 3 cubed. So as I finish simplifying this, 2 cubed is 8. 3 times 3 gives me a to the 9th. And I would also have b to the 9th over 3 cubed is 27. So that would be my final simplified expression. Let's do a couple more examples here. We take a look at number 17. I've got x to the 5th on top and bottom, y cubed on top, and then y squared on bottom. So this would be x to the 5 minus 5, and then y to the 3 minus 2. 5 minus 5 is 0, and anything to the 0 power is just 1. So that's just 1. And then 3 minus 2 would be 1, so what I actually have is 1 times y to the 1st, or just plain old y. If we take a look at now number 20, I've got a power outside of parentheses. I'm going to choose to reduce my a's first. So for my a terms, I've got a to the 2 minus 1. When I don't see that exponent, remember that it's 1. So what I actually have here is 2ab. Remember, we've reduced the a on the bottom with the a squared on top. 2 minus 1 is just 1, so that would give me a to the 1st or just a. Now I'm going to cube this. So that means I'm cubing everything inside. So 2 cubed, a cubed, and b cubed. So that would give me 8, a cubed, b cubed. And now let's take a look at number 21. Same idea. Since I can reduce inside those parentheses, I'm going to choose to reduce first. It just makes some of my later work a little bit easier. I don't have such large exponents to deal with. So I notice I've got p's that I can reduce and r's that I could reduce. I also have 4 and 3 as some coefficients there. If I could reduce the 4 and 3, I would, but they don't have any common factors. So let's take a look at our p's. This would be p to the 4 minus 2. And this would be r to the 4 minus 2. Always top minus bottom. So this would give me 4p squared r squared over 3. And then we're going to cube everything inside those parentheses. So this would be 4 cubed, p to the 2 times 3, r to the 2 times 3 over 3 cubed. 4 cubed gives us 64. And this would be p to the 6, r to the 6. And then again, 3 cubed is 27. So there's a couple problems left for you to try, but we're simplifying by, again, subtracting top exponent minus bottom exponent. And then where I have a power outside of parentheses, it gets distributed into each term. The other type of exponent that we're going to look at today is what happens when we have a 0 exponent or a negative exponent. And we already looked at an example with a 0 exponent just a minute ago, but I want to talk about this a little bit more. So when we look at exponents and we have some sort of integer positive exponent, we know that this means 2 times 2 times 2 times 2, right? So 2 multiplied by itself 4 times. That would give me 16. 2 cubed means 2 times 2 times 2. 2 cubed would be 8. 2 squared we know is 4. 2 to the first power is just 1, 2. So that would be 2. 3 to the fourth would be 3 times 3 times 3 times 3, or 81. 3 cubed, we saw a couple times on our last practice set, that's 27. 3 squared is 9, and 3 to the first is 3. 10 to the fourth power would be 10,000. 10 cubed would be 1,000. 10 squared we know is 100. And 10 to the first is 10. So we looked at a couple different examples of exponents here, exponents in play. I want you to notice that as we reduce that power for the 2's, we're actually dividing by a factor of 2 each time. I've divided by 2. Kind of similar to a geometric sequence that you would have seen in Algebra 1. For our 3's, as we've reduced that power, notice that we've divided that final answer by 3 each time. And then for the powers of 10, as we reduce that power, we've divided by 10 each time for that final result. And that should make sense. We're multiplying by this number one less time. So I could, to go from 10 cubed to 10 squared, divide by 10, take out a power of 10. Okay. Now let's take this same idea and apply it to 0 and negative exponents. So what happens if I don't have a positive whole number exponent? What if I've got 0 as an exponent or a negative number as an exponent? So we're going to use this same idea here. So 2 to the first is 2. If I want to reduce the power by 1, that's what I've done here. I was at 2 to the first, now I'm at 2 to the 0. I could find this answer by dividing by 2. So that would give me 1. Now, if I reduce the power again, I could take my last answer and divide by 2. That would just be a half. And now if I reduce the power again, I could take my last answer and divide by 2. So this one we just need to simplify a little bit. 1/2 divided by 2 means I would have to multiply by a half since we've got fractions here. So that would give me 1/4. Now, if I reduce that power again, I need to divide out another factor of 2. So that'd be 1/4 divided by 2. So 1/4 multiplied by a half. And since we're dividing a fraction, multiply by the reciprocal. So that would be 1/8. And we could do the same thing with our 3's. So to reduce the power on 3, I could take my last answer and divide by 3. So 3 to the 0 power would be 1. If I reduce that power again, I could take my last answer and divide by 3. So I would get a third. Now, if I reduce that power again, take my last answer and divide by 3. So that would be 1/3 times 1/3, which would give us 1/9. And then again, if I want to reduce that power by 1, I can divide by 3. So 1/9 this time divided by 3, which would give me 1/9 times 1/3, which would be 1/27. And then we can use this same process as we reduce those powers of 10. So I take my last answer and divide by 10. Since I reduced that power from 1 to 0, I can divide out a factor of 10. 10 divided by 10 is just 1. When I reduce that power another 1, I could take my last answer and divide by 10, okay, which would just be 1/10. And then if I'm going to reduce that power by 1 more, take my last answer and again divide by 10. So now that I've got a fraction, I've got to multiply by that reciprocal, and I get 1/100. And then one more time here, if I want to reduce that power of 10 once more, I'm going to again take my last answer and divide by 10. So this would give me 1/100 times 1/10, which would be 1/1000. Now, I want to point out some things here. Every term we took to the 0 power, we got 1. And this should be true for every number. So if I were to take 400 to the 0 power, 400 to the first power would be 400. So if I wanted to take it to the 0 power, I could take that last term and divide by a factor of 400, since I'm reducing that power by 1, and I'm going to get 1. Okay? So whatever I take to the 0 power, I should get 1. Now there's a little caveat in here that doesn't work if you're taking 0 to the 0 power. That's sort of a special case. But for everything that we're going to look at, anything to the 0 power is 1. And then there's also a pattern that we can pick out here with our negative exponents. So I want you to notice that this would be the same as 1/2 to the first. And 2 to the -2 would be the same as 1/2 squared, right? 2 squared is 4. And 2 to the -3 would be the same as 1/2 cubed, because we know that 8 is 2 cubed. This works for my powers of 3 as well. 3 to the -1st would be the same thing as 1/3 to the first. 3 to the -2nd is the same thing as 1/3 squared, because 3 squared is 9. 3 to the -3rd would be 1/3 cubed, because 3 cubed is 27. And with our powers of 10, this works as well. 10 to the -1st would be 1/10 to the first. 10 to the -2nd would be 1/10 squared, since 10 squared is 100. And then 10 to the -3rd would be 1/10 cubed, since again, 10 cubed is 1,000. So if I'm taking a number to a negative power, what I really got is 1/, our number to that power. At negative exponents, flips us into the reciprocal there. So if we take a look at this with a couple more examples, 5 to the -3rd, well, that would be the same as 1/5 cubed. So I don't have to work from 2 to the first to get to 2 cubed. I can take advantage of this pattern here. And instead of having to divide by 2 each time to find that next term, I can just flip it into that fraction. So 5 to the -3rd would be 1/5 cubed, which would be 1/125, since 5 cubed is 125. Now here, put this in parentheses, I've got 1/2 to the -3rd. So we just saw a minute ago that when I have an exponent or a fraction, that both the top and the bottom, the numerator and the denominator, they both get that exponent. So that means that in this case, my 1 to the -3rd needs to move to the bottom. Since I have 2 to a negative exponent on the bottom, it's going to move to the top. They sort of switch places in their fraction. So I've got 2 cubed over 1 cubed. That would be 8/1, or just 8. And then for our last example here, I've got 5 to the -7th power to the 0 power. Now, for some of those earlier examples that I did, I simplified inside parentheses first. But for this one, I'm actually going to go ahead and distribute that power in, because that would give me 5 to the negative 7 times 0, which would just be 5 to the 0. And we know that any number to the 0 power is just going to be 1. Okay, that's it for today. We'll do some more practice on this when I see you guys in class.